Yo, Evinia, welcome back. And yes, just in case, thanks for the follow, baby69. How's your days been? So just in case, as you can see, today we are back to coding in this case. But before that, small update. So if you're just watching our stuff whatsoever, like right now, you can definitely see. Yep, I forgot recursion. So if we scroll down a little bit, we can see, okay, here are all the links that we have. One of them is Link Nexus. So if you go there, this will bring us to our website. Down over here, we have all sorts of different links and all stuff. However, what has changed is if we press the logo over here, so we will go back to the main route. Um, Add a small subtle feature. Every time when you hover this thing, it'll expand or whatsoever, make it fancier. But the real thingy is, if you still remember how to get access to our coding stuff that we've been coding on stream or whatsoever, the way you would do it is you come to Learn 2016, come over here, and then scroll down. Now you might realize that, oh wait, something's different. So in the past, we do not have these category buttons, but now we do. And if you hover them, at least now you know what you're looking at. In this case, what we're looking at today is computer science. So when we just click on it, you can see we have other stuff. Now you might be thinking, wait, some of the things are slightly different. Where is X key Enigma? Where is Console? Well, since both of them are C++ projects or creations, they have been included here. C++ projects. So once you click this thing, it may take for a while in order to load and all that stuff. So we come down over here. Yep, this is C++ projects. Scroll down, which is almost the slightly same thing. Scroll down, you might be thinking, wait, where are all the sections? Well, once again, all the hover buttons are all here. Hover on the wrench, you get forward functions. Hover on this, we have lower, which is actually, in the past stream, we call it calculator, which is the calculator thingy that we just built. I can show you, like, whoop, and then let me quickly. So, in the past stream, what we have done is, if I do quickly just ls and then just quickly do this, and then we just press H. Here we can see we have a whole bunch of available operations or whatsoever. There we go. So like for example, we're just gonna go like 45 plus whatever. Press enter a few times, it gives you the answer. Of course, you can include parentheses, and it still follows the what some of the people will call it the PEMDAS rule. PEMDAS rule. So finish what is inside the parentheses, and then spit out the answer for you. What we are going to focus on today is not exactly calculator, or in this case, now it will be called as lower. Why? Over here we have our roadmap, and then one of the items says it will become an interpreter-based programming language. So soon afterwards, Lua will be a programming language using lambda calculus as the main mechanism. So what is lambda calculus? We might able to like take care of that at another time. But what we will be focusing on today is for functions, because for functions, and we will try our best to fulfill these 4 items today. Console clearing, background coloring, table printing, and string slipping. So string slipping would be something like you try to slip a certain smaller string inside a bigger string or whatsoever. It's almost something like adding a string into there. So yeah, we have that. Or there could be a probability such that I have already implemented it, such that I have forgotten that. And then in that case, hooray! So first thing first, console clearing, which is, I would say, quite easy. So let's pull this thing up. The first thing that we can focus on. Okay, let's cross this thing out because we don't need that. Cross this thing out. We'll take a look at that. Okay, so first thing first, it's the cout. So in this case, it should be very simple. Will be something like just clear console. No inputs needed. It's just clearing the console whatsoever. Can I? Okay. Also, the music has stopped. Why? Huh. Okay. Anyway, back to this. Okay, there we go. So clear console. If I remember correctly, in Code to Later, okay, we will take inspiration of that. So basically in C, it's just basically this. So I might just go Control C, and then just paste it over here, and then we're done. No fuss, no muss whatsoever. Also, since we have changed that, I will also need to like change it as well. The version number. In this case, it will be now 30th. 0103. Oh wait, 4. Okay, there we go. So yep, that's the version number right now. So now, for cout has screen clearing now, so that's good. So the next thing that we can look into, like if we go back here, console clearing is done. Next thing is background coloring. So turns out, okay, if we go string, shorthand, color tags, if we can have like making color tags, like we just scroll down over here, like for example over here we color our word or text blue. There is actually also a way to like color the text, but instead it's like highlighting it. Like you pull out your highlighter and then you just color the background of it instead of the text. So we can actually do that. So let's add that to the list. Now I have to admit, I do not know how, but we can definitely look it up. C++, console, text background color. So, yep, there we go, console background. That will work. So, if I'm right, there should be something like an escape character though. Oh, yep, standard lib. I believe we have that. Do we? Standard lib. C standard lib. Well, let's include that, shall we? So in this case, let's go include std lib dot h. Or in this case, yeah, that looks good. Alright, good. So syntax of the color console. Ooh. Not quite like where this thing is going, but huh. Okay. Yep, this is what we're looking for. However, it's not exactly that helpful. P is the color code of the corresponding color. What? Set console text attribute. I do not like that. Well, in this case, you know what? What can be extremely helpful is, since this topic is popular enough, ChatGPT might be able to help. So let's see what we can. ChatGPT, there we go. Now you might be thinking, oh, you're cheating. Well, sometimes we just have to cheat for the right reasons. But please, when you are able to choose not to cheat, please don't. There we go. There we go. Oh, it's not recognizing me. Or is it? Oh, yeah, it's recognizing me. Alright, good. So, I'm gonna say in C++, how to make the text background color. Well, instead of make, let's say set. So, in this case, we will be having in C++ how to set the text background color. So let's see what it says. Hopefully it's something like really easy, like escape codes. Aha! Escape codes. Perfect. Something similar. Good. Good. Okay. Okay. So /033 and then square bracket is the escape code. I believe we have that. So we just come down over here. Yep. We have that. Exactly. Now what is different is this one over here is 0m. Huh. Over here it's 1 semi 3 and then 0m, whatever. Background color 40. Huh. What is this? Oh, 30. So that makes it even easier then. Sort of. Well, if that's the case, I'm gonna just like copy and paste the whole thing. Whoop. Oh, by the way, since I do not need this anymore, I'll just turn it off. There we go. Back to this. Alright. So now, color background. Okay. Color background. This time it's 40. Or let's see. Okay. So it's almost the same thing. Okay, so that resets it. This one over here is 40. For 6, and then finally for 7. Okay, hopefully that works. So let's hit save, and then all over here, something definitely won't be happy is expression evaluate. I think we do not have that at the moment, because now actually what I've done is I had already turned that into its own class, and soon we will be working on that. Now, what we should be doing, yep, there we go. A while ago I was trying to hash some stuff, but yeah. Next, let's remove this. So in this case, we just do forward, C out. Oh wait, no. It should be string. And then we'll do shorthand, color background. In this case, let's just go black, whatever. And then let's just say 0. For now, this is what we have. Of course, what I'm gonna do is I'll just go down over here and then just paste the whole thing. One, 2, 3, 4, 5, 6, 7. And then let's go red, green, blue, yellow, cyan, magenta, and white. And then let's see. Next thing we can definitely look at let's go with default. So let's hit save. Now we're just gonna wait for the terminal. There we go. So we just go G++. Standard is C++11. And then we'll just go just run. And then go test.cpp. Not text, but test. There we go. There we go. And then we'll just run. Just run. There we go. Works like a charm. Perfect. So there we go. Now we have colors. So that's off the board. We're good with that one. So there we go. So now we have background coloring covered. Next thing is table printing. Ooh, table printing. Okay. So table printing. Ooh. Okay, this should be also a string, and it turns one string to another string. So in this case, it should be convert. No. Manipulation. Sort of in a way. Wait. Ooh. Okay, sometimes things are a little bit too complicated in this case, so we will be doing in the parent thing. So anything uncategorizable will be done over here. Let's see. Let's call it so in this case it's a string, and then we will call it. Wait, I have a better idea. This will go under the vector class, and then we will say we will use this to generate a table. So generate vector table. So the first thing is we definitely need vector, but it's a vector of strings. In this case, it's going to be a list of headers. In. There we go. So that's the first thing. Another thing is our datas. Vector in this case, we don't know the type, so in this case we'll just say template type. Oops. So over here we'll just go type, and then let's see. Okay. Okay, let's call this thing in list data. So in this case, it's almost something like if you want to like use for in order to generate a table, you will need to force it to be the same data type, and then put them inside a vector and then print it. So in this case, so how should be our table look like? So what we have here is we'll have header 0, header 1, header 2, and then we'll have header 3, or just n, whatever. And then we will have these. So that's the separator. And then let's say our data sits here. Excuse me. Now the new problem becomes how can we know like, how can we know what's the width of a column? So that's something interesting to think of. Oh boy. One thing over here we can definitely say is, oh wait. One thing we can notice is table width is actually in list header dot size. So that's one thing we definitely know. Hey. So at least we know how far do we have to go down or whatsoever. Okay. Another thing that we can definitely have is we'll just have vector, and then it's a whole vector of int, and then we can say int list, and then we will say header width, or in this case column. So column width. So that's one way to do it. Okay, there we go. I thought I messed up a little bit. Let's see. So assume that if a certain header is a little bit too long, then we'll just say something like this. We just have that. Like, if a header is way too long, just do that. So okay, so let's go with 4. So in this case, we will figure it out. What is the first line? Let's do this like very raw first. Also, the indenting does not look great. There we go. Okay, 4. Deal with the header line first. Of course, over here we'll just say string. Let's call this thing table. For int starting from I is smaller than list header in list header dot size plus plus. But before that, we need to check if that is valid. So we can say if, oh lord, what is this indentation? So what we can say is we just want to make sure that both the header size is the same as the column width list. So in list column width dot size. If they're not different, we will say return empty string for now. Okay. Otherwise, we can continue. So, for every header, first thing first, we will just say we will print this and then the space. So so table is going to be table plus this, and then we will figure it out the header. So at the left margin, next thing is the length or whatsoever. So we can say if wait, header is just a whole bunch of string. Okay, that's the easy part. So in list header, at the ith position, get the length of it. Now, if this thing is way lesser than the width, so in this case we just call list column width I. This will give us a int or integer. So if it's lesser than that, yeah, fine. If it's equal than that, okay, yeah, acceptable, no big deal. Otherwise, if it's too long, so over here I can just like comment like if the header length is shorter than the length, or I can say if the header length is too long, so over here we can say then pad it. So in this case we have that, or do we? Oh no, we do not have padding because this is in vector, not string. Sad. Never mind, we will do this thing raw, I guess. So then pad it. So we can say table is table plus in list header the ith item then pad it. There we go. So in this case, let's go for int j starting from 0. J is smaller than the padding length. So in this case, the padding length, it would be in list column width, get the ith item. This will give us an integer minus our in list header, the ith item, but the length. J++. Then we can say table is table plus this and pad it. And we are ready for the next iteration, like the next header item. Otherwise, if it's too long, then we will crop it. So in this case, then crop it. So in this case, it would be something like for int j starting from 0, j is smaller than, okay, so in this case it's in list column width, the ith, because I is over here, and then we will just do j++. So every time we do it, we'll just say table is table plus, in this case we will say in list header, the ith header, we want to get the character right there. So that should be good. And then, so this does it for every header. When all the headers are done, we will say table is table plus the closing line, and then of course next row. And then, okay, for now we will just say let's return the string. So return table, and then we can actually test this thing out and see if it works. So we just come over here, so we can come over here and do cout, and then we'll just do forward. Forward dot in this case it should be vector, and then over here we can say generate vector table. So int list header, so over here we can say h0 h, or maybe I can say header 0 header 1, and over here I can say header 2, and then the last one I'll just call it column 3 just to be naughty whatsoever. And for now let's just say, okay, it's a whole bunch of int. So the next thing is a this. So in this case I can just say okay, for now that will get cut off whatsoever. Width, let's go with 3, 4, 5, 6. Oh wait, if it's were to be a vector, then you should use curly brackets instead. There we go, that's more like it. And then in this case, let's just go, I'm gonna go for that for now. And just want to like make sure that this thing works. I'm gonna hit save and then see what it outputs. And oh lord, what happened? Invalid use of member function length. Should we do that? Is it? So let's hit save and then recompile again. So it turns out length is a method or function. Okay, so we know that. Let's see. Oh, okay. Okay, one thing I forgot is I'll just come over here and I just go whoop, at the right margin. Now over here you can see, wait, that is not exactly what we need. But you know what? Instead of 3 dots, I think this is good. Because as the user, we definitely know, wait, something got cut off. So yeah. You know what? So I'm going to throw away this idea. So, yep. So now at least we have that. Okay. There we go. Then the separation lines. Wait a second. Oh wait, I might call this the corner then. Or, oh boy, oh boy. Okay. Because soon afterwards, I can definitely say this will be row 0. And then, yeah, we can definitely do that. There we go. So we can definitely do something like this. And we'll just call this thing row 1, row 2. Yeah. We can definitely do something like that. Or should we keep it simple for now? Okay. Let's keep it simple for now. Let's just say all of them are the same thing or whatsoever. Or, like right now, we don't even focus on this whole thing on over here. We just focus on what is on the right for now. So, Next, it's the separations lines. So, same thing again for every of that. So first, we can definitely say table is table plus this thing. Next thing is for every header. Then the separation lines. So say for, well, let's start with int j0 j smaller than column width. So in this case, list column width. However, the ith of it, but +2. And then we'll just say table. The reason why we need +2 is because of the left and right margins or padding or whatsoever. Table is table plus minus sign. And then when every one of them is done, do the same thing. So in this case, if we were to like run the whole thing again, oh, bruh, it's here. Huh? I didn't mean JN. What in the world? Oh! I forgot J++. Still. Okay, this is a weird bug. I just declared it over here, J starts at 0. Don't tell me that we need this. And then let me guess, they're just gonna say, wait, do you mean KN? Bruh. Bruh, this is stupid. Oh, that's why, because of a semicolon. Oh lord, that is really weird. That is really weird. Now we can run this whole thing again. There we go, and then we run it. There we go, perfect. Now, the content. Then the content. Ooh. In this case, we need some sort of like coordinate system though. Okay, let's see. So let's go for int I, starting from 0, I smaller than in list data size, meaning for every item in that list, gonna print it. So we can say like table is table plus this and then the left margin, and then ooh, wait a second. Oh, yep, we definitely need but you know what? This might not exactly. You know what? I just move this whole thing to forward because this is so amalgamated in some way. I just cut this whole thing, and then we'll just come down over here, and just poof over here. So the moment when we hit save, this thing over here won't be happy at all, because first thing first, it should be here. Next thing, it should not have a vector. It's just that, generate table. There we go. Okay. So now we can focus on that. This also means that every fancy thing we have seen so far are all available now. So let's see if we can clean up some of the stuff. Then pad it. So the way to pad it, let's see. For string, okay. Or do we even have that though? Oh, it's just that. Oh, okay. String, and then let's go manipulation, and then we'll go padding. What do we want to pad? In this case, it would be table. And then we will fill it with space. What's the size? In this case, it would be this. Or wait. In this case, it should be column width. Yep. And then character align. Ooh. Let's say we want to align it left. Okay. So but wait. Let's see. We have this thing, pad it with that, and then add it to the table. There we go. Table is table this thing. Whatever this is, doing some padding over here. Otherwise, crop it. So it feels like trimming instead. So what we can do here is we just come over here, paste it. Over here we can say instead of padding, it's trimming. Start with the string. In this case, it would be our header. And then int start, let's go with 0 until our width. In this case, -1. And then add that. Save it. At the right margin, separations line, content. For now, let's just make sure that this thing works. Oh. Yep, that's all. Alright, there we go. Sometimes we just have a missing semicolon or whatsoever, so that's actually pretty stupid. And there we go. Works like a charm. Okay. Separation lines, then the content. Paste it. So in this case, the spring representation of it. What we can say is we will do forward. Or we can say, okay, for whatever converts to string. So is it this thing? Anything to string, yes. So it's in our string class whatsoever. Okay, so let's go strong, and then we can say convert, and then anything to string. So that's a string representation of like whatever value you have, int, float, char, whatever you have there, it'll work. And then, oh boy, in this case it should be int list data, and then say this thing. So this will become a string. Now we just have to like crop it. So in this case, I would just say string, and then I'll call this thing step 0. Get the raw stuff is what I would say. Next thing, forward, or I should say, yeah. Now we just need to like pad it whatsoever. So it's a manipulation, doing some padding. In this case, it should be box stat 0, and then fill it with space. Next is the size. So in this case, it's the column width. However, in column width, it might run out of bounds. So we need to be careful in this case. So in this case, it should be I mod, and then the header count. So int list width dot column size. So mod that. That will give us a number. And then align. Let's align it left for now. Or another thing that we can do is column width. Okay. Over here we can definitely say vector. And then char in list column align. So over here we will use the same approach. In list column align. The ith one, however, mod in list column align dot size. So this will give us the padding. This is box step 1. Next, box step 2 would be the trimming. Under manipulation. Yep, there we go. And then we'll go trim. In this case, box step 1. Box step 1. And then start. So from 0 until excuse me, the column width. So in this case we are good. Then we can say add the space, and then if the whole row is now done, this means that if I is equal to some sort of thing, so I mod in list header dot size -1. Oh wait, paste it over here, paste it over here. We have that. Then we will say ready for the next row. So in this case we need a bar and then \n. Okay. So let's just hit save. So we come back over here. Oh. Yep. Column align. Let's go left, right, left, right. Um, so in this case, we'll have that. And like, to be honest, I'm going to expect something will go wrong. But let's see, how wrong will it be? Oh, that's really wrong. Oh, let's see. Like all the datas are all gone. So let's see how we can fix that. Endless data. Oh, that's why. Because I forgot to include box step 2 over here. It just throws away after all the hard work. Still? Let me try that again, just to make sure that... Huh. Anything to string. Oh, that goes our type. Huh. Okay. String, that's our header. Next thing is the column width. The next thing is a whole bunch of char. The next thing is the data. So the parameter passing is correct. Step 0. Okay, let me just see out. Box step 0. Box step 0. Box step 1. Box step 2. Box step 2. We'll just see what goes wrong. Oh, we haven't saved that. Huh. That explains it. Still. Okay, let's take a look. Oh, step 2 is completely gone. But why? Trim. From step 1. Starting from 0. Okay, how about this? We trim it first and then we pad. Because if I remember correctly, now come to think of it, if the ending position is outside of the range, it just gives you an empty string. So cut it, paste it. This is now 1, this is now 2, this is now 0, this is now 1. So we first trim it, just to make sure it's short enough. If it's way too short, then we pad it. So oh. Huh. Okay, you know what? I'm going to fix the trim function over here. So convert. No, it's manip. Trim. So if any naughty thing happens, just yep, it just does that. So how do we fix this? Okay. Okay, let's do this. So trim, save. So in this case over here, it's the same thing. Now we'll just go if somehow we go in string dot length, and then we go end. Then we will say in this case we'll just call trim in string. In string. And then the start. Oh, wait, we need some clamping. Okay. So, let's go with pause, start, int, pause, end. To make things a little bit fancier, there we go. Forward, math, or do we even have that? This is string. Okay. Math, forward, math. There we go, so we have that. So now we do forward math. Do we have clamp? Yes, we have. Low and high. So low is 0. High, it will be in string length. However, I'm gonna say treat this thing as a float. And then start. And treat this thing as a float. And then what it comes out, treat it as an int. There we go. Do the same thing. In this case, E. Over here, over there. This time, E. Then, in string, start should be pause S and pause E. Okay. So in this case, this thing is using this thing up here. So if we come back down over here, in this case, we will be using trim safe. So let's just hit that, and then save it, compile it, whatever. Still no? What in the world has gone wrong? At least we know this thing is correct. Like, box step 0 is correct, but box step 1 is wrong. Fine, let's see how trim really works. Start is 0 until oh boy. Uh, Possess. Pause E. Let's see what it says. So over here, okay. Wait. Okay, I think I know what's the problem. Instead, should be length -1. There we go. That's more like it. Okay. So we'll just remove that. So that's trim safe. There we go. Come back over here. We don't need this anymore. So technically speaking, we have this. So I would say that's good. So now we have this nice table over here. So we just come over here and I will just say 8, 8, 8, excuse me, 8. And then all of them will just say align right. There we go. Perfect. So if afterwards you have like mixing data types, you will need to convert all of them into a string and then print it. So yeah, we can actually do a really quick example. Now, you know what? One quick example is we can actually try to use no VOD over here. So in this case, we just go into our storeroom and then just bring out no VOD. In this case, it should be this one. So yeah. Sure you want to move the current? Yes. Okay. So now we can use Nova. So we're just gonna go include no vote. Okay, because I'm going to print something real weird. Or what we can do is wait, no, not here, not here, not here. In this case, let's go back here, and then up here we're just gonna say include no votes. There we go. So you know what? Let's call this node. Okay, a whole bunch of nodes. Missing? What? Whatever I call it. Wait, we have already included that, didn't we? No vote is over here. And it's public. Huh. Oh. Yeah, I still need to tell it what thing to store. You know what? Let's say float. Hey, whatever. So what stuff does it has? It has the content, it has the pointers, it has the flag. So just come over here and then I can say for int I starting from 0, I smaller than 10, yeah, whatever, I plus plus, we are going to generate 10 nodes or whatsoever, so and they're going to store float. Content. Let's go with I, but interpret this as a float. And then we can say list no votes with a weird spelling. We can say pushback. New node. So now, with that, that will contain a lot of those. Now what we can do is we will start generating our data vector. So in this case, let's just say vector string data vector. For now, it contains nothing. But what we can do is we can say for int I starting from 0, and then I smaller than list node size I plus plus, meaning for every node put stuff inside. So what it's gonna do is list node, take the I. This will give us the content or whatsoever. However, what I can do is I'll just go forward and then just go, because remember, we can actually turn any data type into string now by using forward. So forward string anything to string, so that's actually a convert. So in this case, it would be list node, the ith, the content. This will be a float. And then data vector dot pushback, and this whole thing over here is going to be a string. The string representation of it. Now, do the same thing for flag. The flag in this case, it will be a int. Other than that, it's the pointers. Pointers. Ooh, interesting. So in this case, a pointers is a vector of no votes. However, a pointer to it. Or is it? Let me take a look. Ooh, sneaky. So over here, it's a float. There we go. Aha! Wow. Wow, okay. So in this case, we can actually start generating our table now. Let's just cut that thing, paste it over here. The first thing that has been pushed to our stuff is container. The next thing is our flag, whatever value you want to mark it with or whatsoever. And then we can have pointers. Oh boy. Let's go with 32. This one will be aligning left, aligning left, aligning left. And then when everything is good, we will just say data vector. And it's not that. In this case, it's a whole bunch of string. Not quite sure if this will work. And guess what? I'm expecting segmentation faults. Oh. Oh lord. What? That's a lot of stuff. Let's clear it for now and then just recompile the whole thing. Oh lord, how many? Oh no. Oh, okay, so it means that it cannot be done in some way. Okay. Okay, let's see. Let's note, get that stuff. Pointers. In this case, they have some of them. Interesting. Because I was like thinking, okay, we can actually print out pointers. After all, it's actually just address. Okay. This is going to be tricky, but I'm gonna do it this way. So int j starting from, oh no, not I, j, and then we have that. As long as j is smaller than whatever we have up here. Whoop. Pointers size j plus plus. Let's note I or you know what? I believe you get the same idea. Okay, I would say this is a huge mess right now. Let's start from scratch, like clean. And then I'm calling this LN. Or LND. So now, wait, so you know what? I'll just go normal this. So NDL. In this case, it will contain float. So what I can do is NDL dot, can I go insert by order? Okay. So in this case, I'm gonna just like randomly do stuff. Or I was like thinking if we can like keep on inserting a whole bunch of them. No, not yet. Oh, okay. Control C. So in this case, there we go. Now we have that. So technically speaking, we do not need these. Or you know what? Let's just start clean. So in this case, just want to like make sure ndl.print node. Let's go with horizontals. For now, just want to like make sure that everything goes well. So whoop. So now we have these, which is good, I would say. Now what we can do is no VOD, float, star, in this case an arrow, I call it X for now, and then arrow X is NDL root. Now while arrow X is not null PTR. In this case, I will now start making the data vector. So it's a vector of strings. So first thing first. Oh, the content. Turn this whole thing turn string convert anything to string. Put it over here. In this case, it will be a float. And then we can say data vector pushback. So that will be our first thing. Next, it will be our flag. In this case, an int. Now, the weird thing. What do you mean by you have nothing called a flag? Oh, okay. Now the pointers. So for int I, starting from 0, I smaller than, now this is weird, arrow x pointers dot size I plus plus over here I call it pointer box. For now, it's something like that. So what we can do is arrow x pointers, the ith one. Now turn this whole thing into a string representation of it. So in this case, let's go for string convert anything to a string. In this case, it's going to be a pointer. And in this case, it would be this. And this will give us a string. So this means pointer box will be pointer box plus whatever this is. So now pointer box will be ready. So now all it needs to do is to just push back pointer box. Now, just want to like make sure that things are working fine. Can we like force print it? Huh. Convert. Vector. How do we print the whole thing? So, array to vector. Nope. Is that cout? Ah, yes. Force print vector. String. In this case, it's our data vector. Vector name. No name. Left side. Let's go with a space. Separate. Space as well. Wait, if that's the case, then nope, no left side. No, no right side. Padding length. No padding. Align. Let's go with left. Padding string. None. So this will give us a string, and then we just go cout endl. So not sure if this will work. Let's see. It works. Huh. So, oh, I forgot. Arrow X will become arrow X pointer to the right hand side of it. There we go. So now it traverse everything. Whoop. Still. Fine, let's see. Cout arrow X. Let's see. Let's see what it is doing. So that's strange. Okay, I'm just gonna say just to see. Chunk A, and then it got stuck here forever. And then chunk B. Huh. Force print vector. Interesting. Let's see what it is. Let's see what's the issue is. So in this case, it's an cout force print vector. Is there like well, technically speaking, this thing should end. Let me just go IS now. So and then nothing happens. So that's very odd. First we have chunk A and then chunk B never comes out. So force print vector got stuck. -1. Wait. So padding length. Padding. Huh. Might work. So padding, where is it? String, manip, padding. While box length is smaller than int size. So our int size is -1, and then well, technically speaking, huh. So basically you should return, like immediately return box. What if I say 16? You know what? I'm going to do it the raw way. I'll just do for int I, and then I smaller than data vector dot size I plus plus, and then we just do cout data vector, what is in there, and we just do that. Go okay. So technically speaking, this part over here works perfectly. Now the new problem becomes force print vector does not work. Or is it? Wait. What is a set fill? Padding string. Oh, that. Oh, that might work. Huh. Oh. Well, that explains it. Yep, there's a whole bunch of crazy stuff going on. But yeah. So at least we do not need this now. So so we can say if padding string is an empty string, then we just need to say warning, it will not work. Do we have cout above us? Oh wait, this is cout. Oh. Okay. Console quick. In this case, error. We just say padding string is empty. Will not work. ENDL, and then return an empty string. Okay, so that's a safety feature. So now, since we know our data vector works, now we can try to print the whole table. So what we can do is we just go for generate table. Oh, it needs the type. In this case, it's a whole bunch of strings. So our header, in this case, we can give it. The first thing is going to be our content, and then our flag, and then our pointers. Next thing is our column width. In this case, let's go with 8, 4, 32. I don't know, we'll see. And then column align. This time we align right, and then we align right. But for the pointers, we'll align left. And then our data vector. This will give us a huge string, and then we just need to like print it out. So save. Save it. And then run it. There we go. Beautiful. Beautiful. One thing though, I'm gonna add a space in between them. So if I do the same thing again, whoop. Huh. Pointer box is this thing. Pushback pointer box. Interesting. The moment when I add a string, then they're gone. So that's the odd part. It's just an extra space. Oh. What if let's say it's not a space. Let's say it's a letter Z. What? Bruh. So a Z is acceptable, but not a space. Why? You know what? Just print out the pointer box. And let's just go to the next line. So pointer box. New line. Ooh. That is like really weird. However, I would say there might be some hidden characters. So in this case, a comma would be good. So yeah, we have that. There we go. So just in case 0 over here just means it's null pointer. So yeah. So if you want to like print mixed datas, turn all of them into strings. Then you're ready to print. Okay, so that's good. Next. So now we can print tables. Next, string manipulation slip. Oh, okay. Yeah. Not sure if that's already implemented or not. We'll see. So if you use like manipulation, trim save, vector concat, substring replace, hex assign extend, padding, space cleaning. Okay. So in this case, we'll just say slip. So over here, we can say string, in string, and then a int position, and then we can also have another string in. Let's call this thing substring. So in this case, okay, first we need to like say if okay, you know what, let's clamp it. So for we still have math above us. Yep, we have that. Math helper. There we go. There we go. So math helper, clamp. Low is 0, high is the in string dot length -1. And then we need our position. Meaning if it overshoots, it just says, alright, attach at the end. So in this case, we'll just go with that. Oh wait. Int. Let's call this thing slip position. Now, for int I start from 0, as long as I is smaller than slip position, or you know what, we can do the trimming though. So we can just do trim, and then we can go with, you know what, maybe no. Let's say this one is current position. Starts from 0. So we can say while current position is not equal to slip position, so over here we have deal with the front first. So up here we have a string. We can call this thing plate. For now it's empty. Whoop, there we go. And then we can say plate is plate plus in string dot at current position. Okay, and then we can say current position plus plus. So this will move on to the next one. So when we arrive to the next one, then it will break. Then we can say, alright, time to slip in the stuff. So plate is plate plus in substring, then we can just keep on moving on. And then now when current position is smaller than in string length, then we can say yep, deal with the in this case, let's call it rest. And then we can just say return plate. Okay, so let's hit save. So to test this, we can throw everything away. We can say cout for in this case we're doing string and it's sort of manipulation, and then it's slip in string. I just say 0 and all the way up over here, and then say position. Okay, I'm going to be naughty first. Let's say -1 or -2, whatever. And then in substring, I'm gonna say ABC. Or maybe I can say for int I, this time not start from 0, this time start from -2, and then I can say I smaller than, let's say 15. I want to overshoot in this case, so I++, and then do the same thing over here, so cut, and then we'll go paste. Whoop. So over here we go I. Whoop. And then that should be good. So over here we can say ABC got stuck right here until this one over here. And then this is when I is 1, which means the substring will be at position 1. Continues until it got stuck right over here. Okay, so this thing works. Now one thing we can do is highlight, but let's not focus on that, because when we want to do some highlighting and some color stuff, the way that we did it is multiple escape characters, so that becomes harder. So yeah. Excuse me. Alright. So technically speaking, if we look at our roadmap today, we have done everything we need. So, yay! So technically speaking, I can just end the stream over here. However, you know what? We can actually do a little bit more. So let's just go here. So in this case, for functions is done. So all I need to do is to like update the version number. Yep, and then hit save. There we go. So we have that. Next thing that we can definitely look into is LOWAR, or lambda assembly, how, as I would call it. Like, there are many alternative ways to call it. For now, we don't need nodes. Over here it's called call1, but I'm going to rename it to LOWAR. So this one over here becomes that. And so far everything seems good. In this case, expression evaluate, I'll just say statement evaluate. Here we go, and then just do this, do that. For the operators, debug mode, well, so far we don't need that right now. So, one thing that you can definitely do wait a second. Okay. Oh. Yep. Yep. Now, calculator. Expression evaluate. Experimental. Oh. No. Core. So this time over here, this one will be lower. And I'm going to expect a lot of wrong stuff. Waiting for the red highlights to come up. Yep, there's a whole bunch of them now. There we go. There we go. In this case, we'll just go C out, lower, statements, evaluate, and then the whole thing. Still, some of them are off. Forward vector removed by next. Oh. Okay. There we go. That should work. So in this case, if we try to compile it, we can go G++ minus standard is C++ 11 minus O, we call it lower. What was it called? Calculator. You know what? I'm going to call this thing, let's rename this thing. We say lower drive. So yeah, whoop, lower drive. CPP. Oh, okay. So over here, 1, 2, 3, 4, 5. Okay. Oh no. For functions 2595. Huh. Two 595. What's that? Two 595. Okay. Bruh. What? Oh, wait. Oh, there we go. So now, if we come back over here and then do the same thing again. There we go. If we just go clear, and then we go lower. Yeah, it's the same thing. So okay, so we have that. However, what we can work on is we just come over here and then. So now our new question will be something like, how should a statement looks like? Okay. Also, the attention pin. I was like thinking about like using a semicolon in order to separate the different statements. So it might work. This also means that as long as I've reached a semicolon, my attention pin should stop there. So in this case, we cannot use find object pause. Or wait. I think yes, we can. So we just do this. So this means if it sees a semicolon, then it stops there as well. So this means that if we don't see any closing parentheses, if we don't see any semicolon, then we know the whole thing is done. Otherwise, yeah. Okay. So technically speaking, well, at this point, the pins, the attention pins, will be staying on the parentheses. Now focus on the whole attention span. Okay. Another thing is for the operators, look for the actions. So in this case, we just go int act pause group. Let's say 0 for now. And then we'll just copy. In this case, the thing that we should be looking for. Okay, funny enough, if we have something what we call C out, can we say something L out? You know what? We'll just say print. How about that? Just print. Good old print. Just that. For now. Okay. Searching direction. Starting from the left. So over here is else if act pause group 0 is found. Then we can say pin 0 is act pause, and then pin 1 will be pin 0, pin 2 will be pin 0 as well. Then it depends on what is pin 0 pointing to. Look for statement end. statement end. So in this case, it should be just this. Like, I call this thing semi-pause. For now, not exactly it, nothing. So let's just say if the whole statement only have one semicolon, what will happen? This thing will look for it, so attention E will be there, and E will be 0. This thing will also be 0. So basically speaking, all of these will be like all -1. So the whole attention span, both of these will be 0. All of these will be 0. Oh, that will be 1, whatever. But we will be focusing on pin 0. So else if pin 0, oh wait, string segments pin 0 is a let's say semicolon, then basically say callRes string will be nothing, just nothing, and then yep, just replace it with nothing whatsoever. And then we're done. So now the stopping criteria becomes as long as it's bigger than 0, then yeah. Okay, so we have that. So now we know that every statement must end with a semicolon. Otherwise, weird things might happen. I don't know. The next thing is print. So print should be over here. So else if string segments pin 0 is print, then this means that now pin 1, excuse me, should be pin 0 plus 1, and then we can say pin 2 is also pin 0 +1 as well. So we can say just see out. Forward. I want some colors at this point, so let's go string, shorthand, color. In this case, let's go with whatever, blue. Okay? And then just say lower. Okay. And then say forward, string again, shorthand. This time is color text. This time it's default. And then print out whatever, like string segment, pin 1. Or you know what, let's just do this. So so that's print. So that's what we have. Not sure if this will work, but well, let's see. There we go. Now we can do lower. So it's right there. Now we can say fine, let's do something really simple. 6 plus 10 ends with a semicolon. So let's just, oh no, pin 0. Huh. Okay, interesting. Let's see what it is. So why does this happen? Let's see. You know what? Let's do debug. Debug mode set to 1. Print 6 plus 10 semicolon. So now here we have the whole stuff. Our attention. Oh. Okay. 0, 1, 2, 3, 4. So at least this one gets it. So attention pin S is wrong. Okay. So at least we know it's this. Look for this thing, and we have that. Oh, okay. Okay, over here I'll just trick it and then just say if pin attention is -1, then we will say pin attention should be 0. Save it. So we have that. Hey, exit, compile. There we go. Run. Okay. Now we can say print 6 plus 10 semicolon. So over here, yep, we got that. Huh. Okay. Interesting. I want this to like Okay, you know what? Wait, let's just make sure that it ends. Emergency halt. Oh, okay. So, first thing first, the printing is totally fine, perfect. So, let's say for now, let's just go ENDL for whatever. Now the next thing is okay, let's see what it is. Let's turn on debug mode, and then let's just go print 5 times 86 semicolon. Okay. Okay. Now, attention. What if we just huh? It's strange. A lot of strange things. first we have this. Okay, you know what? Just to make things a little bit cleaner, let's just recompile the whole thing. And then just say print oh wait, so I still didn't have that? So let me hit save. Now once we're ready, we'll continue from here. And then now we'll just go print. So what is strange is there's something hidden over here. But why? What is that thing? Okay, I'm going to be sneaky enough. Force print vector. We have padding left and padding right. Item left side, item right side. So in this case, I'll be doing that just to see, is there anything sneaking there? Hey. So wait. That's odd. Oh, we can say, okay. Else if user input vector 0 if it exists, then typically do nothing and then go out. So just come over here. recompile. And then just do this, and then we can just do print. So we have that. Now, this is something sneaky, like, where the heck did this thing comes from? Oh wait, it's the print. Oh, it's the print, it's the print. The print over here. Oh. Oh no. Okay. Color res. Ooh, okay. Okay. We'll say if color res is not this, then we say pushback. Otherwise, oh wait. Okay, I'm going to say this. Ignore. So we have that. So we have so print over here, the color res should be ignored as well. And then you know what? At this point, let's just go. Yep. So this means it will do whatever. And what's wrong? Oh, yep, there it is. Also, one thing we can do is what I would call cleaning. Okay, sometimes the string segments may contain tokens that should be ignored, like empty strings or strings that contains a hashtag at the front. You know, at this point, I might just say, well, because maybe under some circumstances, they might have some extra actions that we can give. I don't know, we'll see. So, we can say, well, vector, and say over here, string segments new, I remember. Yep, there we go. Cut this thing. These will turn really red. They will be not happy about it. In this case, whoop. This is needed for plate manipulation. Like empty strings or okay, so string wait, okay, I'll do it this way. So int I and smaller than string segments dot, nope, it's the size I plus plus. Do this like if oh lord, we can say for vector find object position vector. So among this list is the thing that we want. Okay, and then our target. In this case, it would be string segments I. Starting direction. Let's start it from the left-hand side. Now, if this thing is bigger than -1, meaning wait, if it equals -1, meaning it's not found, then we want to include it. So string segments new pushback. In this case, it should be string segments I. And then when everything is done, string segments is string segments new. Okay. So let's hit save. So at this point, print should give us ignore. This thing should give us ignore. So yeah. Done. So now do the same thing. Boop. And then now we can do print this thing. Let's say plus that thing. Go down. Whoop. Oh no. What in the world just happened? Oh wait. Okay. String segments new should be clear. Okay. Oh wait. Whoop. Whoop. There we go. Oh no. It's exploding. This is why I don't just literally run everything in while loop. Oh, Mika. Why not switch? Oh, you mean, oh, here's the thing. So if you're asking like, why not using switch for strings? Right? Is that what you mean? Is that what you meant? Like, why not like do switch and then in case of this thing, then case do that, something like that, and then break. I wish I can do that for strings as well. Now the only sad thing about strings is it's not compatible with switch in this case. Only if the things that you're comparing to, it's an int or a float or a double, then it can do a switch. For a string, sadly no. But yeah. By the way, how's your days been? For now, let's just do a quick clear. Compile it. And then just run it. So now we'll just do print whatever plus whatever. Do that. Hope. Ignore. Okay. Cool. Huh. So when it only has a single semicolon. Interesting. Alright, let's see. Or you know what? Before that, let me just go debug mode and just go semicolon. Whoop. So in this case, yep, both of them focused correctly. Okay. Out of range. Oh, okay. Okay. Yeah, I know the issue is right here. How about for now, we'll just go with that. And then... what will happen for parentheses? So if this thing is pin 2, and then... Okay, pin 0 plus 1. 0 plus 1. There we go. Use me. Alright, let's hit save. Okay. Let's see. Whoop. And then we'll do lower. And then we'll do print, whatever, times whatever. So this will give us that. Okay. This will give us that. This will give us that. Okay. So over here, let's say if string segments dot size, and technically speaking, run successfully and return done. So that should be good. So recompile. Do this. There we go. And I would just go print. There we go. Perfect. So yeah. So if this is the case, okay. Wait. Okay, and then we'll come back here, /e. Okay, so let's just do clear now. Alright, so if everything done right, this means that we can run multiple statements in the same line or whatsoever. So let's see if this thing works. Okay. So now we have this. Now we print this plus that minus this. Multiply by that. Also, it will just say print whatever this is, multiply whatever this is, mod whatever this is. And it ends with a semicolon, or we can have no semicolons at all. So let's see one by one if it can do it correctly. So in this case, yep, it got stuck right over here, and it just messed with this one already. The next thing is this thing. We end up with that. Next thing should be this one. End up with a big number. Now the next thing that should happen is print it. So at this point, this thing is done. And then this thing will become ignore. Now work on the same thing. Syntax error. Okay, let's see what it is. In this case, it's modulation. So maybe that's a little bit too big outside the range whatsoever. Syntax error. Okay. Number is simple. Oh. Built-in double. Built-in double give us a boolean. Built-in double give us a boolean. Okay. Hit save. And then for now, let's just redo the whole thing. So at least now we know that we can do multiple lines of statements or instructions. Let's try this thing again. Lower. So let's go print whatever, multiply by whatever, and then mod this number. Do the same thing for print whatever, multiply by whatever, divided by whatever, and then multiply by whatever again, and then plus some funky numbers. And then mod some other numbers. So just go. Syntax error. Huh. Hmm. Well, I didn't like it. Alright, you know what? I'm going to do it this way. Let's hit debug mode. And then we will copy this whole thing. Print it again. So let's see what went wrong. 0 to 6. No parentheses. 0, 1, 2, 3, 4, 5, 6. Okay. Has a G2, which is right here. Multiplication. So that's the thing. So 0 to 4. 0, 1, 2, 3, 4. Okay. Also has a G2. And then it's this one. At position number 2. 0, 1, and 2. So I'm thinking it has problem dealing with this one. Oh wait, I should have done it the other way. So if any one of them is giving a false, then I throw a syntax error. Oh, okay, that makes sense now. Okay, so I come back over here, exit, recompile. Run the same thing again, clear the whole thing, paste it over here, do the whole thing. Yep, there we go. Now it prints 54. 54 over here. Ignore that one, goes away. That one goes away. Work on that one. Now, technically speaking, this thing will be worked on first, which is this one, and then becomes that. Okay. That's a plus sign. Okay, I'm thinking it will mess with this one first. Yep, and then multiplication. Yeah. Addition, modulation. Yep. Huh. Is it? Wow. Huh. Good. So there we go. Now we can run multiple statements. Yay. So yeah. So that's a good thing. Okay, let's see. Just in case, I'll be right back. Made a small mess. Okay, and we're back. However, something's off. Wait. Ah, there we go. Alright. That's more like it. So, yeah. Now we can have multiple stuff. Now, what should be helpful is, assigning things. However, in this case, we need to come up with a new mechanisms. Which is something like make a variable out of nowhere. So, this would mean something like, over here, we have a list of constants. So over here, we just say, over here, we have a whole bunch of string, and it's a list of variables. So, yep, that's the thing we have. In this case, let me do a quick there we go. Like a quick note of how to denote these stuff. So basically the main idea is like every time when we like, oh wait, I take it back. No. Okay, maybe afterwards we can deal with functions calling. So in the code, let's see. But basically speaking, every variable over here will be stored as a string. So yeah. So print from left to right. This case equal sign. uh, you can also say first we need to like make a box. Like we need the ability to like define a variable. So I was like thinking either we go for def or let or var. You know what? We'll go for var. So int act pos group 0. Or technically speaking, every statement can only have one action. For now, we'll see. Var. There we go. So if we find var pin 0 var declaring a variable. So whoop. However, okay, I'm going to be like very sloppy right now. So at this point, if you decided to name your variable a number, please don't expect things will work. No, it will be treated as a number and things will mess up. Declaring a variable. So basically it just means that. But how can it be? Expecting. And the name. Var. Name. Let's see. Hmm. Initial value. Oh, wait. So var. Okay. Hmm. Excuse me. Also, you know what? Maybe I should throw away the last one. So, um, okay, I'm going to say save for now. And then just come over here, and then just say done. Compile it. For now, things will be weird a little bit. Like, for example, I want to test. I just want to say, for now, we do not accept strings yet. We only accept numbers at the moment. However, this should give us just Rugru. It works. There we go. There we go. And then we will say syntax error. Close. Yeah. Okay. Close. Yeah. So... Wait. What if we say... we say print... whatever. There we go. Perfect. So yeah. It also works, so that's good. You know what? I'm going to be strict over here. Like, we need an initial value. If alright, let's see. Well, at this point, we are syntax checking. So, string segments, init values, okay. You know what? Technically speaking, we can just say list variable pushback. Simply just say string segment pin 1. No. And also pin of that. So this also means that pin 1 will be pin 0 plus 1, and then pin 2 will be pin 0 plus 2. Okay. Also, color as will be ignore. So in this case, con will not be con anymore. Instead, it would be ref con. And then over here, it should be ref var, meaning refer to variable and then give me the value. So we have that. Next. So I'm also like thinking, let me just copy and paste the whole thing. So just go else if refcon is now ref var. So basically, found index, this thing, found object, list, variable, if this unable to find variable, this thing, variable area. Over here we can say constant area. So we hit save. Okay, hit save. And then so now over here, let's just do something really simple, I guess. So at this point, I'm going to say var apple. Let's say it's 8. Okay, and then I'm going to say var. Oh no. Var lemon. Let's say 7. Okay, and then I'm going to say print ref var. I want apple plus ref var. I want lemon. And that should be good. Hopefully. So the first thing first is that thing got entered into our list. And then yeah. Next thing, lemon with a value of 7 got added to our list. Next, it understood apple as 8. Soon afterwards, it will understood lemon as 7. 8 plus 7, that's 15. Print 15. And we're done. Hell yeah! Now, the only weakness is we can keep on using it. Like, we just do, hey, we just do print ref var apple, right? And then you just go, yep, it's still there. However, can I do something like so let's just say I'm going to say var, I'm going to say knife. And then I'm going to say ref okay, let's say knife for now is 0, okay? And then I'll say knife equals, wait, have I set up assignments yet? No? Oh, okay. I haven't set that thing up yet, so it'll end up with a syntax error. Like for now, yeah, you can only declare it again and then make it that way. Okay. Just in case, among this whole thing, oh, var equal and then print. Okay. Var, and then we have this. Else if string segments pin 0 is a equal sign. So now we know expecting in this case it's a name and then equal and then a value. So in this case we will be checking you know what, how about no, we're just gonna do it this way. In this case we will be referring to ref var. So in this case paste it over here. First thing first, try to find it. everything before it. If we cannot find it, we cannot find a variable error whatsoever. Otherwise, we can say this variable found index plus 1 equals to string segments pin 0 plus 1. So this one is -1. And then call res. At this point, it should be ignored. So basically, it's almost something like, based on this thing, try to find it in the variable list. If you didn't find it, say, nope, can't find it. If you can find it, set the value of it, and then you're done. So hit save. So now, oh. So for now, I'll just go compile. Run it. So in this case, we can say var, I'm going to make apple 8, var lemon 7, and then I can also say var knife, for now 0, or I should say question mark, whatever works. Okay, and then I can say knife will become ref var apple plus ref var lemon. Okay, so what we should expect is apple will be 8, lemon will be 7, knife will be unknown. However, knife afterwards will get these. Okay, so let's go. Next we have, okay, lemon will turn into 7, 15. Oh, emergency halt. Emergency halt is over here. Act pause. Huh. Okay, pin 0 is the main thing. Strange. Okay. Debug mode. So we just copy this whole thing, paste it over here. For now, it should be fine. So start is 0, 1, 2, 3. Yeah, perfect. 1, 2, 3, 4. I think we can print that thing out. That should be helpful. Act pause. G0. And then another thing would be semi-pause. Okay, so that's the thing we have. Debug mode on, and then copy everything from up here. Do it, and then just go. Semi-pause is -1? Oh. Among... okay. So over here, let's see. It's unable to find that. Act pause is 0. What about the equal sign? Because I was expecting you to find it over here. Between S and E. String segments and all these stuff. Left. This one is act pause. Act pass group 0. If any of the pins goes outside, Right, so right here, why I didn't find it? Like, and in this case, it just finds it. Ref var, okay. Wait. Huh. This thing should... Well, you know what? Let's go from left to right. Yep. Let's go from left to right. And then let's see if it works. Because there is something in there, which is also known as searching direction. So now at this point, let's just try this thing again. Do this, alright, and then we will say make a var, call it apple 4 this time. Make another var, lemon. This time call it 5, whatever. And then var, call it knife. For now, I don't know, give it a question mark, whatever works. Next, I can say knife equals refer to var apple plus refer to var lemon. So in the end, we have that. Oh, that's a problem. Yep, this whole thing should become ignore. So if that's the case, okay, well, at least we're getting there. So in this case, let's just go pin 0 is pin 1 minus 1, and then pin 2 is pin 1 plus 1. So basically this thing, that's the name, so that's actually pin 0. So unable to find variable pin 0. Otherwise, this variable found index, assign the value, this is actually pin 2. So, yep. Do the same thing again. So this time, var apple 8, var lemon 7, var knife this thing. So, and then we say knife is ref var apple plus ref var lemon, and then we're done. And then we're just gonna say print ref var knife. So and we're good. At least we got 15 right there, so that's good. Because we are printing knife or whatever. So ref var comes first and then print. Over here, equal sign, yeah. So yeah, now we can assign and refer to variables. So interesting. So this also means that if we can somehow create functions, then either we can do iterations or we can do recursion. So that's something interesting. Okay. Now, now the new problem becomes, how can we start defining a function So in this case, it will take some of the inputs, and then just give you some output. So the first thing first, it's definitely the name. Input, 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 separator, and then just output. So basically the main idea is like when we want to find a function, we just keep on looking until we find the name. And once we find it, alright, start munching in some of the inputs that it will get. And then by doing so, it will replace some of these things whatsoever. And when you're done, spit out this thing until you hit close, and then you're done. However, put this onto your statement plate, or in this case, string segments. So that would be interesting. Because with this, then we can start making recursive functions or iterative functions. So that's pretty interesting. Oh Lord. Oh. Damn. However, there we go. Also, I wonder, can we have a vector of a vector string? Huh. Vector of a vector string. Huh. That would become neat to some extent. You know what? Let's see. There we go. Yes, we can. Okay. So that's good. So in this case, we have a whole bunch of functions and then, you know, whatever. So, okay. So, now, new question is, how do we make a function? So in this case, declaring a function. I would say, if you want to declare a function, do it in a single statement. So, okay, let's just do it that way for now. Go. Okay. Function, and then okay, maybe ref con. Ref function. So we have that. Okay. So that's a var. Now else if string segments pin 0. For now, function. So declaring a function. So in this case, we are expecting inputs. Until outputs. Thank you, Cork. Thanks for the follow. Legend? Not yet. Still working on it. But yeah. Anyway, how's your days been? You're working on anything fun? So here, function name, input, function open, output, function close. So we have that. Let's see. Just in case, basically speaking, it's just adding the whole thing into the list. Oh, okay, let's see. Been a good home. Was about to start a stream up. Oh, got lost just visiting others. Cool. They came across you coding, which is sick. Tried studying code, but I get dried out fast. Well, let's see. Okay, so for example, how should I say this? Because the main idea would be something like, you say you get dried out fast. From my experience is something like, if you are overdoing it, then you get dried out fast. So what I would say is, when you start learning stuff, learn it step by step, like not all at once. So yeah. But I would say, different codes or different programming languages is is designed to act differently. Right? Okay, I can actually pull out real quick. Let's see. Whoop. Let me pull out Paint real quick. There we go. Paint. There we go. So that works. So come over here. Whoop, 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 and then we'll just go whoop. So basically, programming languages. Like, okay. By the way, I need... How do I even... Whatever works. So, programming languages. There are different types. Like, first, it's general. Like, basically, it's meant to do anything you can think of. So in this case, classic example would be C or C++. Like, can I quickly switch to green? For examples, it can be C or C++. Or in this case, C#, but I'm going to hold that back because another thing is object-oriented. So object-oriented treats everything like an object. In this case, it should be C#. C# is one of the examples, and turns out C++ is somewhere in between over here. And of course, there are something else. Like, for example, there is this like something called a assembly, which is basically talking to hardware. So you have to think iteratively. So if you have ever heard of recursion, in assembly you do not have that. You have to mimic recursion. And then finally, another thing is functional programming, which basically uses lambda calculus. But yeah, it's basically everything you see, it's all functions. There's nothing such as values. There's nothing everything you get to use are all functions. All functions, no variables. There are only inputs and outputs, no variables, no boxes. So yeah, all of these act differently, and they are used for different reasons. Like, for example, you use C in order to do hardware thingy, or I should say something like, you use C in order to do something low level enough, but still high level enough for human readability. And then low level enough in order to manipulate memory and all that stuff. C++ over here, well, you can use that for like applications or consoles, just like the one that I'm using, like, or just like the one I'm making now. Like this one over here, it's all C++. C# can handle a lot of objects in the same environment, and this is why Unity uses C#. But of course, other stuff uses C# as well. .NET is one of the frameworks we have. However, still, I've been looking into like .NET these days, and then, oh boy, let me tell you, it's like you're rolling a dice, and then you don't know whether will it get to work or not. And if it does not work, it's not because you're coding, it's because of your hardware or environment, and then there are no tutorials or fix out there. Even if they do, most of the time they'll end up with no solutions. Now, assembly over here, you're doing something like completely low-level stuff. You're just literally telling what's happening between the registers and all that stuff. However, the reason why you might use assembly is because it's fast. And then if efficiency is what you want, then yeah, go ahead with assembly. Or you're dealing with a specific hardware, right? You're dealing with a specific hardware such that these hardware has their own little parts, right? And then in this case, someone will have to figure it out a sort of language in order for the others to use this language in order to control these hardwares over here. So we have that. So you use assembly in order to do something like, you want like fast efficiency? Yeah, okay. You want to do something with a specific hardware? Okay, yeah, good enough. Like for example, something like GPU stuff. Okay, yeah, you want to like literally just tell the GPU how to render stuff on your screen or whatsoever in a very low level way. Fine, use assembly. Functional over here, I have to admit, so far for now, I do not see like any real life examples using functional programming. However, I can see where this becomes useful to some sense. So yeah, and from what I heard is functional programming, it's available in C#, it's available in Python, and it's available in JavaScript. So yeah, we have that. And soon afterwards, hopefully enough, available in Lua as well, which is the thing that we're working on. Or instead of Lua, it should be Lambda OWA. So yeah, whatever. Pretty stupid. So yeah, there are different reasons for you to use different programming languages. So yeah. And you're a very good teacher. Well, just in case, thanks. However, I'm not a teacher at this point. I'm a student. Are you into any cybersecurity? Well, guess what? I'm taking that this semester. However, there are a lot of fun stuff though. But if you want to look at like cybersecurity, one thing you definitely need to look at is modular arithmetic. So modular arithmetic is a whole new system of math calculations in order to see things from a totally different perspectives. Like, for example, here's a quick example. I'm gonna just go with, let's just say 8 plus 5. We just immediately know that is 13, right? However, if you limit yourself, let's say, from now on, I can only have numbers from 0 to, let's say, 7. Then, what would this whole thing become? So this whole thing will just become, how do you squish 8 into this range? So basically, the way you would do it is modulation. In JavaScript, okay, in JavaScript, we use the percentage symbol. Basically, it's almost something like, okay, if I take 8 and then 3 over here, basically it means 8, but mod 3. Another way to understand it is something like, you take 8, you divide it by 3, and then you take the remainder. So in this case, you'll end up 2. Okay? So in this case, 8 mod 3, that's 2. Okay? So basically, if you want to achieve this, but under this case, if you want to like map anything between 0 until 7, this is actually known as mod 8. So 8 will just literally become 0. 5, you take 5 and then you mod 8. However, 5 is smaller than 8, so it fits perfectly, so it's 5. And then 0 plus 5, you get 5. So that is modular arithmetic. Or another way to see it is something like, you have a clock. You have a clock, and they go from 0, 1, 2, and then 3, and then 4, 5, 6, and then 7. So the way that you do it would be something like, originally you start over here. Okay? Wait, let me do it this way. Whoa. Okay? So basically in mod 8 would be something like, let's say you start at 0 and you add 3. Okay? 1, 2, 3. You add another let's say 5. 1, 2, 3, 4, 5. And then you add 4. 1, 2, 3, 4. So basically in modular arithmetic, you're basically going in circles. And then in addition, you're going in the positive direction. And then once you want to subtract, you go the other way around. So technically speaking, in mod 8, if you have 2 minus 4, under normal circumstances, we just say negative 2. But basically in mod 8, you have 1, 2, 3, 4. So in mod 8, 2 minus 4, you get 6. Although it sounds stupid, however, it works under some circumstances, and we need them in this case. Why? Because we need this in cryptography. And then, basically speaking, one thing you can definitely look it up is Caesar cipher. So Caesar cipher takes all the letters, A, B, C, all the way to X, Y, Z, right? What they do is, what Caesar cipher does is, it just shifts it. So let's just say I'm going to shift it 1 and 2. So at this point, A becomes C, B becomes D and all that stuff, X becomes Z and all that stuff. And in this case, it wraps back, like A and B come back over here. So basically, it's actually mod 26. Caesar cipher, like classic Caesar cipher, is mod 26. So basically you would do that is, basically the way that you would do that is you turn ABC into 0, 1, and 2. Then you can start doing math on it. So let's say you have a Caesar cipher with a key of 5. So you just plus 5. So it becomes 5, 6, 7. And in this case, let's say you have 25. 25 in normal alphabet, Caesar cipher, that is the letter Z. If we go from Z and then you shift 5, over here you end up with 30, but because of mod 26, this means you can take 26 away from it and you end up with 4. So it's E. Z becomes E in Caesar cipher with a shift of 5. So yeah. However, I have to say, Caesar cipher is really weak. However, it's really a good example to understand basic cryptography. So yeah, if you want to look into cryptography, definitely look into modular arithmetic. And once you understand some of the modular arithmetic stuff, then you can start diving in some of the encryption algorithms and understand how they work. Like I have to say, RSA, you might have heard of it before. I heard of it as well. I tried to look online. Computer File did cover it a little bit. However, it did not exactly explain why it works. And then what I've been planning to do is I'm going to talk about RSA in one of our future videos and covering what is not covered by Computer File about RSA, like why it works. Like if you go to Computer File and then just search RSA, yeah, you can immediately search and find out how it works, but why it works, they didn't come up with like a really good explanation. So that is something I will do. So basically, if you're not quite sure what I'm referring to is, you can go to our team's website. Just in case, if you scroll down a little bit, you can see in our about section or bio on Twitch, if you're watching this on Twitch, there is something called Link Nexus. So once you go to Link Nexus, let's see, is it here? Well, it's loading. There we go. After all I have is a potato laptop. Once you go to I haven't reached Link Nexus yet. Okay, so there we go. So if you click on Link Nexus on Twitch, you'll end up here. Okay. What you can do is you just scroll down. We have a whole bunch of like YouTube channels. One of them is Learn. If you click on it, this will bring you to our YouTube channel. And oh, it's still loading. There we go. In this case, we will be using VRChat as our medium in order to discuss math stuff. Oh boy, I'm lagging. There we go. So these are all the episodes we have so far. However, if you want to know what we will be talking about, what you can do is you just come over here and then just go Learn, which is this button over here. Scroll down and then you can come to like MISC or Miscellaneous over here. Click on it. Here we have a button and it's VRChat Classroom. Click on it. This will bring you to our VRChat Classroom page. So we have it over here. Scroll down. These are all the episodes we have. Keep on scroll down. Here we have our roadmap. So as you can see, we are working on logic gates, but technically speaking, Recursion and Tower of Hanoi is ready to be released. thing that we definitely need to work on is modular arithmetic. We will need to cover that. And once we have covered modular arithmetic, then we will say in cryptography we are ready to go with Diffie-Hellman and RSA and some other crazy stuff. So yeah, because cryptography uses a lot of modular arithmetic. So yeah, if you want to look into like cybersecurity and all this stuff, look into modular arithmetic before you dip your toes into cryptography. Because if you're like me, without properly knowing modular arithmetic, I just jump into cryptography immediately. I know some of the symmetric ciphers. However, for some of the asymmetric ciphers, I was struggling. So yeah, look into modular arithmetic. You're gonna love it. Maybe, hopefully, hopefully. But yeah, that's what we have so far. All right. Whoop. Back to this. Now, declaring a function. Let's see. Okay, I'm going to say pin. Oh, this will become something interesting. Well, at this point, attention span will be. Okay, let me just do it this way. Attention start, and then attention end. And basically speaking, pin 0, and all of them will be here. You know what? I'm going to let pin 2 walk. So basically, it would be something like while pin 2 is lesser than pin attention E, okay, let's do vector string. Let's call this thing function strip, and it's a new one. For now, completely empty. So at this point, pin 2 is the same as pin 0. Okay. So I'll just say pin 2 is pin 0 plus 1. So at this point, pin 2 should be pointing at name. Hey. Let's see. So at this point, function strip new, pushback, string segments, pin 2. And then when we are done, we say pin 2 plus plus until when pin 2 is that. So basically speaking, when the whole thing is done, pin 2 minus minus, so that it will step back here. And basically, this whole thing, like calc res, it should become ignore. And then also we will say list function pushback. In this case, it's our function strip. New. There we go. And that should be good. So if we come over here and do K is for constant. Oh, sorry, I just missed the message. Let me see. Will the man have a whole book where I studied handwrote a bunch of stuff about cybersecurity? Ooh, like networking concepts. Okay, cryptography protocols. Oh, okay. Hash functions. Okay, good. Web vulnerables. Okay. And a few more little subjects. My parents think I'm crazy. I would say when someone thinks that you are crazy, it's because they do not fully understand you, so they think that you're crazy. Sometimes people will think that I'm crazy as well, but yeah, fine, whatever. So yeah. So I would love to know the tools that can help. Have you tried any bug bounties, like on Hackerone or anything? Bug bounties? Let me search it up what it is. Let me search it up. What do you mean by that? Bug bounties. Let me take a look. What is that? Oh. Oh. Okay. That makes sense. Feel like you would do very good in it because knows a lot about code. Well, not exactly. Like, okay, yeah. There are many types of like students like us. Or yeah. So in this case, okay, first, oh boy, my throat is dry. I'm gonna hydrate myself first. Oh boy. Okay, there we go. So, knowing how to code, not exactly almost something like immediately know what, feature of that language to use immediately. Like, okay, like, I have to admit, like, for example, a while ago, guess what? I was using ChatGPT. why I was using ChatGPT? In order to figure it out how to like change the color of a text. Now what ChatGPT gave me is, alright, it gave me this little segment over here so that we know, hey, every time when the console sees this thing, it knows that, alright, time to change the color, whatever, right? So I was like thinking, okay, yeah, I'm not gonna like memorize all of these weird number thingies and all that stuff. So what a raw coder would do would be something like, for that specific case, like for example doing a cout whatever, it would just enter the code like /033 and then open bracket, say this, and then keep on moving on, and then just copy and paste all over the place, right? But what I would do and what I've done is, if we go to forward functions, which is, oh boy, a monster. At this point, we can go like forward string shorthand. Over here you can see, hey, we have color text, we have color background. So everything over here, we have taken care all the colors we can have, and all you need to remember is the representation of the colors you want. In this case, D for default, K for black, R for red, G for green, and all the way until white. Same thing for color background as well. So I call that secondary coding in this case. Like primary coding is like looking at a specific raw question and then figure it out the raw method to do it. Secondary coding is what I would say something like, how can you make this thing easier to access? However, there are more layers upon this thing. Like for example, it's almost something like, can you come up with an algorithm or a solution in order to fix some certain problem? Like for example, one classic example is, okay, if you know data structure, then that's good. Binary tree, right? Binary tree. So the main idea would be something like, let's just say you want to print everything, right? How are you going to do it? Well, the classical way, what they would tell you, right, is you do this recursively. However, recursion has its own risk. One classical example of recursion is just Stack Overflow. And the moment when you run into Stack Overflow, the whole program will just halt, the whole program will just go kaput and will not work. So to some extent it's dangerous. So a new question would be something like, can you figure it out a new way to print the whole tree without using recursion? And actually, yes, you can. The way you would do it is with a counter. However, this is both good and bad at the same time. If your data structure allows you to have an extra small part, then yeah. So the way to do it is, I would call it the flag. So a flag can be an integer whatsoever. For now, all of them will have a flag 0. Right? And then you start from here. So when you see something is 0, then you know, okay, This one is not done yet. The left side is not done yet, so I'll go left. Same thing over here, same thing over here, but over here you say something like, okay, at this point it has no children whatsoever, so I'll print you. There we go. Print that thing. What it does is it updates the counter. Now look at the whole thing again. When I'm looking at the counter and the counter is 1, it means that, alright, time to look on the right hand side. The problem is there is no right hand side for me to look at. Okay, then I'm going to update my counter to something else, let's say 2. And then when you look at the counter again and you know it's 2, then you know, okay, right hand side is done. Back up. So come back up over here. And then you just use the counter to like update for that certain node if you have already taken care of the left side, the right side, and printing itself and all that thing. So in this case, you can use a counter. So I would say that's a this is what I would call the 3rd level of coding, which is able to solve a certain problem. And coding is not just like knowing the exact syntax, because after all, if a language is popular enough, syntax is all over the place, and then you just need to search it up, and then you're good. So yeah, we have that. But I would say, and admit I'm not exactly really that good. If I were to be really that good, I would have .NET MAUI running on my potato laptop already. However, it still does not deploy. And then if you use .NET MAUI before, or for those who are watching the VODs, when you want something to deploy in .NET, you just go to the configuration manager and then just check the tick boxes and then allow it for, like, you know, deploy and debug. And I did that. However, when I wanted to debug it, it says, hey, you didn't take the tick box. And I was like, bruh, it was there. So yeah. Yep. If you know what I mean, then that's good. Alright. Back to this. So, well, over here I would just say else if user input vector 0, print config. I should say memory. So we just print everything. Niwo irue, or wait, irue. Oh boy, I'm not a linguist. Sorry, I can't pronounce your name real right. Irue. Oh, my tongue. Okay. So just in case, what language are we using? Okay, so in this case, this is C++. C++. So in this case, C++. Like back in the days, we start from C, and then some of the people were like, okay, yeah, C is cool, low level enough, but way too low level. Plus a lot of weird quirks. So we were like, alright, we're gonna make something like a new version of C. It's C. It's the same thing, but better. So that's how you get C++. So we have that. And there are a lot of good stuff Like for example, in C, when you want to print something, okay, you definitely see printf, and then whatever is inside, right? In C++, you just do cout, and then whatever you want. And it's user-friendly. It's user-friendly. This is just one example of the difference between C and C++. Like in C, you just have you have to type printf, and that's a lot of stuff. And then sometimes you have to mess with the format, and then the format in this thing over here, it's not easy to read. However, if you go cout, things are much easier to read and know what is going on. So this is one example. Another example of like the difference in between these, okay, is that function calls, right? When you have a input which needs to be passed by a reference, let's say an int, the way you would do it is you passed in a pointer instead. Okay? You pass a pointer, and then you just mess with the pointer. You reference it, dereference it. Okay, in theory, like to me personally, okay, at least I know this thing is a pointer, so I know what to look for and what to take care of. However, some of us that thinks like, alright, pointer notation, pain in the butt, let's make this easier. So what they have done is, afterwards, when you want to make a input passed by reference, you just add this thing in front of it. Then what they have done is they came up with a compiler to say, look for this thing, look for the ampersand. If you see an ampersand in front of a name, then you know this name or this input is passed by reference. All the pointer notations will be taken care in the declaration part. So yeah. So that is another good stuff. But yeah. And technically speaking, still one of my favorite is in C++, because it lets you manually handle the memory. You need memory allocation and memory release. Still, I have to admit, like, for those who are C users, when they look at this, they're gonna be like, there's no such thing as M release, it's something else. Well, I have to tell you, I can't think of it on top of my head. However, in C++, all the memory allocations and all the memory release will be taken care by just simply new and delete, and that's it. You don't have to like worry about a lot of weird stuff going on. So yeah, there is always a trade-off in different programming languages. Some programming languages are meant for low levels. Some programming languages are meant for high levels, like for human readability. Like we have machine code, machine code over here, and then we have assembly, and then we have some other general stuff like maybe C, or maybe something like C++, or maybe something like C#, or maybe something like Python, JavaScript, whatever works. So based on your different purposes, you will use different type of languages whatsoever, right? So yeah. Iria, I'm new to programming. It's my first year in college. Oh, congrats! Yay! So, well, I would say programming languages, it's almost something like learning a new language. So I would say, so just in case. So just in case, asking the chat, the whole chat, how many languages do you all know how to speak? Like for me, I know 2 languages, English and Chinese. So yeah, you can definitely know, whatever. I'm a Chinese, a boring one at this point, but yeah, whatever. However, to me, to some extent, computer languages is a new language. So, oh, you only know one? Okay, it's okay, it's okay. Hey, Cook. Oh, studying Russian? Well, I don't speak Russian. Anyway, if you're studying, technically speaking, you sort of know 2 right now. So, we're on the same page, whatever. But I would say, knowing a new programming language, to me, it can be considered as a language. It's just you're not using this language to speak with humans. You are using this language in order to speak with machines or computers. It is still a language though. Like, oh boy. However, in the world of programming language, there are a lot of like families, like C, C++, C#. All of them, they will look alike. JavaScript, okay, JavaScript and C++, excuse me, almost look alike. Python over here, to me, many people love it, but to me, is a pain in the butt. Fortran, on the other hand, it's even worse. Fortran, it's killing me. And then, of course, HTML. Okay, some people say, hey, HTML is not a programming language. HTML, well, to some extent it is. To some extent it's not. Whatever. Same goes for CSS. Whatever. That will work as well. And then there are other stuff. Right? Sometimes these languages, they will have their own dialects or extra parts. Like sometimes you have Node.js, sometimes you have Express, sometimes you have React. You definitely heard those before. Or maybe something like database, right? SQL. Sometimes they have their own dialects, like SQLite. That's one of them. Another one is Postgres. What else? Another one is MySQL. So as you can see, they're splitting off in their own, and then technically speaking, all of like C, C++, and C# over here, we call it the C family language. So technically speaking, these are actually all languages. So yeah, so to the VOD viewers and to chat, everyone who's here, if you're learning a programming languages, yeah, you're learning a new language. And heck, you can even make one your own, like the one I'm making now. Really learning from this stream. Thanks. Happy that you learned something. Oh, thanks Irie for the follow. Alright, let's see. Print memory. Well, gotta print everything. So let's see. For in this case, I have a whole vector, and then can I print the whole thing? No. Then how did I? Okay. Not clear. Not debug. Constant. There we go. Ah. Okay, that will help. Now I just copy this thing. Whoop. And just paste it over here. Constant list. Do we have? Oh. Okay. Well, if that's the case. Whoop. And then I'll just do over here it's variables, and then over here is constants, and then okay, this becomes something interesting now. For int I, this thing, and then we just go what was it again? Okay, it's lower. The function stuff. Ah, yes, this function. That thing. Okay, I plus plus. And then just over here, I'm just gonna say functions. Whoop. Oh. Don't forget that it's always okay to have Google or ChatGPT by your side. True, true, agreed. The best proc even needs them. Yep. My girlfriend gets worried she need to use it. Okay, but it's all part of the game. I don't get the feeling that you have to remember everything, because you definitely won't unless you're superhuman. That's the point. That's the point. ChatGPT is everyone's savior. Well, to some extent. To some extent. Like, here's an example. Here's an example why you have to use ChatGPT carefully. Okay? Here's an example. I'm going to exploit it real bad. New chat. So over here, I'm just going to give you an example, like, give me the entire list of Morse code. Keep on going. So over here, ChatGPT is like spitting out every character and then their Morse code equivalent, right? Okay, if I remember correctly, oh lord, that's way too. That's way too much. Okay. So now, for example, if I take a look at the letter J, we know is dot dash dash dash. Alright, so let's see if this time ChatGPT can figure it out. So dot dash 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 is J. Oh, this time it caught it. Okay, because last time when I was like trying to like train myself in order to like memorize Morse code, ChatGPT messed it up. The same thing again and again and again. Another good example is one classical example is how many R's does strawberry has? Gotcha! Gotcha! One time I can't find what was wrong with my code and ChatGPT saved me. True! Same over here. However, there are some limitations. Like, just look. I ask, how many R's does strawberry has? And we as humans, we count, okay, slowly, but we get there. 3 R's. Look what it says. Look what it says. Oh no. Oh no. ChatGPT can't count. Oh no. So that's bad. So this is one of the limitations. So not exactly every time ChatGPT will always give you the right answer. You have to be careful with it. However, what I would say is something like whenever ChatGPT gives you some feedback or answers, do not rush to just like copy and paste. See if the things that it gave back to you make sense or not. If it does not make sense, ask ChatGPT to give you an explanation. Bro, can do complex things, but can yeah, I'm testing that. I did not think it would mess up on something so simple. Oh, okay. Okay, Cook, tell us the result. Tell us the result what you get when you're there. But yeah. But basically, now the new problem becomes something like, can you make a function such that it counts how many characters there is? Now I'm testing that. Yep. Alright. Now, let's see if I can like paste everything. I would say this also depends on how things are understood by language models. Like one good starting point, or one thing all of you or everyone can definitely look at is on YouTube. Shout out to Tree Blue One Brown. He has been making videos talking about AI and all that stuff. Definitely go take a look at it. And for the first few videos, he is referring to machine learning in a general sense, but in the later videos, he starts covering how ChatGPT works, and I would say that might help because the way that the thing that we didn't realize is we recognize a string of words or sentences by tokens. So in this case, a token, it's a small unit, it's a small part It's almost something like an atom. Oh, wait. Yeah, it's almost something like an atom. That if you recognize some sequence of them, you might be able to recognize what molecules that you're dealing with, and that's the word or whatsoever. Like for example, I'm going to use the English word, a classical one, undestructible. Right? Undestructible. Okay. So like in this case or example, like for normal human, like, right? What they all see is just one word. That's it. But for native English speakers or sometimes students or whatsoever, they will see sometimes we can just break things up into smaller parts. So sometimes what is a single word might not be a single token. So like for example, when ChatGPT sees this, he's going to focus on like, okay, I see the word destruct, okay, so it has something to do with destroying things, maybe creating things, I don't know, whatever works. And then I see, oh, able. So I know, okay, it should be a something like a boolean trying to say something if something can or not be destroyed or whatsoever. And then I see, oh, okay, I have to flip the result. Or saying something like, nope, you can't do that. So this is how ChatGPT sees the whole thing. But basically, from Tree Blue One Brown, what he found out is every token has its own vector. Right? Has its own vector, whatever it is. The way to understand this vector is almost something like, this is how ChatGPT understands the word. Like, in this vector, it contains a lot of parameter. Maybe something like, is this thing a noun? Is this thing a color? Is this thing a name? If this thing is a color, okay, how blue it is, how red it is, how yellow it is. All of that information will be ingrained in this single vector. So this also means that there is also a chance that you can come up with some vector, okay, that it makes sense to ChatGPT. It also slightly makes sense to us, like when we think of it, like, okay, I sort of kind of get what you mean. However, there might not be a specific human language translation. So that's one thing. And then afterwards, Tree Blue One Brown just like keeps on like explaining like how these things like communicate to each other or how it ends up with the result it gives us. So yeah, we have that. By the way, Cook, what's the result you get? How many R does Strawberry has on your end? Oh, no. Okay, I pressed the wrong button. I pressed the wrong button. I was at the edge of death. Alright, next thing. Next, copy this whole thing, paste it over here. Okay, cout force print vector function, the icon. Okay, So I'm going to hit save, and then I'm hitting save over here. Now we can just test this thing. Might work, might not work. Okay, exit on this thing. There we go. Done compiling. Now let's run it. One thing I can definitely do is print memory. So this prints everything. So wait, that seems odd. Oh, that's one. Okay, hit save. Come back over here. Exit. Recompile. Oh, gonna go. Alright, see you afterwards, Iria. Yeah. Good day. Yeah. Okay, let's see. Run the whole thing. Print memory. And that's everything? Okay. So now over here, I'm going to say function. Name. Ooh. Trip mall. I'm going to call it trip mall. In A, in B, in C, and then function open. In this case, it should be in A, multiply by in B, multiply by in C, and then I say function close semicolon, and then whoop. Whoa, syntax error. Okay, let's see what it is. So we come over here. Oh. Oh yeah. Okay. That makes sense now. Okay. So because it just starts looking at this thing, and then they're gonna be like, nope, can't do that. Okay. Let me think. So in this case, function. Okay. Declaring a function. Ooh. Hmm. Okay. Think I know what to do now. So in this case, OPR, uh, hmm. Hmm. Oh boy, this thing's gonna be hard. Like, we can just like give a quick example over here. Just like go function, just like what we called it. Trip mall, and then in A, in B, in C, and then inputs. In this case, we'll just say function open, and say in A, multiply, in B, multiply, in C, function close. Okay. So in this case, this thing happens before everything. So technically speaking, all of these hmm. You know what? I would say this is a good pausing point. Yeah, I'll work on this. So yeah. So in this case, let's wrap it up quickly. Just to see what we've worked on today. So if we come take a look at this, we have finished all the roadmap for for functions, and then for lower, now it's slowly becoming a programming languages, and then update logo. Haven't done that yet. Implement Boolean operations. Well, not yet, but we'll get there. So now lower can now declare and refer to variables. So that's good. So afterwards, I will upload it. And we have this one over here as well. So yeah. So that should be good. Yay. So I will be updating that. Okay, so let me close this thing. There we go. So yep, just in case. Before I end the stream, let's do one thing. Since Halloween is coming, Google has decided to come up with a small game. So, Momo the cat is back. Oh boy, this is going to be good. It's been a while I haven't played this thing, so let's go. This will be the last thing for the stream today. Okay. Huh. So there are more stuff. Okay. Oh. Oh. Okay. Oh, that's completely new. That's new. Oh. Okay, yeah, it's the same. Okay, good. But I believe slightly harder now. Alright, let's see if I can do this. Okay, good. There we go. Whoa. Okay. There we go. Oh boy. There we go. Oh. There we go. Oh, there we go. Alright, perfect. Atmosphere. No way! So we keep on going up. Okay, let's see. Whoa! Okay. Oh, okay. Huh? What is it? What is that? Okay, that's really that's a new symbol. Huh. There we go. Okay, the swirly symbol is hard. Okay. Alright, next. Whoa. That was fast. Okay. Ooh. Okay. Not quite sure what that is, but okay. Whoa. There we go. There we go. Oh boy. Like, it's always the up and downs. Oh boy, that is the hardest thing. Alright, let's see. Huh? What? Oh. Not sure what it means, but okay. Oh no. Oh, oh, okay. Okay. Hmm. Okay, I didn't saw that. There we go. Nice. Alright. Final stage. Oh. So there's a lot of storytelling over here, so that's good. Alright, let's see how this can be done. Oh, is that it? Uh-huh. Oh, is this like low FPS thingy? Oh, slow down. Oh, so that just means slow down. Okay, got laggy over there. Not quite sure why, but okay. Oh, come on. Oh boy, this one is definitely harder. There we go. So there we go. Happy Halloween, everyone. Oh wait, wait, part two? No way. I'm looking at that afterwards. But yeah. So yep. So for those who are watching this to the very end, thanks for watching. And yes, I will update and upload follow functions and lower over here. So yeah, thanks for watching, and I'll see you next time.